Hey there! So, in the world of data, we're always told to hunt for one thing, right? A significant result. But what if I told you that simple yes or no answer is actually making us miss the best part of the story? Today, we're going to look beyond that simple checkbox to find out what's really meaningful in our data.
For years, I mean decades, this has been the question. It's the big gatekeeper of scientific discovery. It's the first thing pretty much everyone asks when they see a new study.
And, getting a yes to this question was a huge deal. It was like a ticket to the big show. It meant your finding wasn't just a fluke, and you probably had something worth publishing. This became the gold standard, the ultimate goal. But, as we're about to find out, chasing this one goal can sometimes lead us way off track.
So, to really get why this is a problem, we first have to break down what this famous question is actually asking.
Okay, so at its heart, statistical significance is basically a reality check. It uses this little probability score, you've probably heard of it, called a p-value. And that p-value is supposed to help researchers figure out if the effect they're seeing is the real deal or if it could have just happened by pure random luck.
And here it is, the magic number, p less than 0.05. For ages, this has been the cutoff. If your p-value drops below this number, bingo, you get to say your result is statistically significant. But, and this is a big but, a low p-value doesn't automatically mean a finding is actually important.
So how do people even get that p-value in the first place? Well, when you're comparing two groups, one of the most common tools in the shed is something called a t-test.
A t-test does pretty much exactly what it sounds like. It just looks at the average scores from two different groups and tells you whether the difference between them is big enough to be legit or if it's probably just background noise. Now, t-tests come in a couple of main flavors. You've got your independent samples t-test, which you'd use for comparing two totally separate groups, like, say, an experimental group versus a control group. Then you've got the paired samples t-test. That's for when you're measuring the same group twice, like a classic before and after study. Both of them are chasing that same thing, that all-important p-value. But here's where the plot thickens. If you rely only on that p-value, you can walk right into what I like to call the large sample trap. And this right here is the absolute crux of the issue. When you have a massive sample size, like thousands of people, even the tiniest, most insignificant real-world difference can give you a super impressive-looking p-value. The math just kind of works out that way. It'll shout significant, not because the difference actually matters, but just because you threw so much data at it. Let's make this real with an example. It shows the problem perfectly. Imagine we're testing two new teaching methods. In study 1, we've got a small class. But in study 2, we have a huge sample, like 1,000 students for each method. Now just take a look at these results. Okay, so in study 2, we get a p-value of 0.003. Whoa, that is way below our 0.05 threshold. By the old rules, this is a home run. Pop the champagne, we've got a highly significant finding. But hold on a second, let's look closer. What was the actual difference in test scores? 2 points, a measly 2-point gain. I mean, come on, is that really worth overhauling an entire school curriculum for? Probably not. It's statistically significant, sure, but it's practically meaningless.
All right, now let's rewind to study 1. Here, the p-value is 0.08. That's above our magic number. So this study would usually just be tossed in the failed experiments pile. Not significant, they'd say. Nothing to see here, move along.
But look at that difference. The students using method A scored a massive 20 points higher. 20! Now that is a result to get excited about. It's incredibly promising, even if the small sample size meant it didn't have enough power to hit that magic p-value. This is the real story, and the p-value almost made us miss it completely. So how do we avoid falling into this trap? How do we make sure we spot the 20-point bombshell and don't get distracted by the 2-point dud? Well, we need a better tool. So let me introduce you to effect size. Effect size asks a totally different question. It doesn't really care about random chance. It cares about impact. It measures the magnitude of a finding. To put it simply, it tells you how big the difference actually is and whether it's, big enough to care about in the real world. In fact, some researchers have called effect size the most important parameter of all. And for good reason, it gives us the crucial context that a p-value all by itself just can't. So what does effect size tell you? It tells you the magnitude, the actual size of the difference. That helps you judge if a finding is practically important or just trivial. And here's the best part. Unlike a p-value, it is not thrown off by your sample size. A big effect is a big effect, whether you're looking at 10 people or 10,000. It's the perfect solution to our large sample trap. Now, to be super clear, this isn't about just throwing p-values at the window. Not at all. It's about pairing them up with effect size to get the whole story.
Here's a good way to think about it. The p-value tells you if a difference is likely real. You know, that it's probably not just a random fluke. But the effect size comes in and tells you if that real difference actually matters. Is it big enough to care about? You really need both to know what's going on.
So at the end of the day, when you're looking at any kind of research, don't just stalk at the p-value. You got to ask two questions. First, is this effect even real? That's your statistical significance. But then, the crucial follow-up, is this effect important? That's your practical significance, and you measure that with effect size. And always remember our example. A really promising study can have a huge effect size even if it isn't technically significant. Using both of these tools together makes you a much, much smarter consumer of data. So the next time you hear that a study found a significant result, I hope you'll know to dig a little deeper. Don't just ask if it's statistically significant, ask if it's meaningful. Because that's where the real story, the one that actually matters, is always hiding.